Hello everyone, in today's video we are going to talk about transformation of a function. So now take a look at this function, y equals to x squared. The red one is the first function, y equals to x squared. And what happened if I change the function into y equals to x minus 4 squared? Do you notice that the function shifts to the left from the original function, the right one? Also, we can do something, what about plus 4? Then, that means shift to the left. If you minus 4 is shift to the right. But what about I add 2? So the function shift up, right? So if I minus 5, the function moves down, the whole function. So here is the shifting transformation of a function. If you add or subtract certain number at certain position, the function is going to change. Okay, as you can see, there's a two direction, right? One is vertical shift. So vertical shift is when the new function g of x equals to the original function plus some number. If it's plus a, that means it's going to be shift up. If it look like minus a positive number, it's going to be shift down, like we showed it earlier in our example. Let me show you again. So if I subtract 5, the original function is x squared. So the whole function subtract 5, it moves down. But now if I want to add 5, look at the blue function. It moves up from the red function, right? So that shift up and down. And then that is because you add a to the whole function. All right, so now we have a horizontal shift. Well, horizontal shift is when you add or subtract something from a, not the whole function, from x, not from the whole function. So that means if you add an a, remember adding, because I said it wrong when I show it to you. You're going to shift to the left. When you minus a number, is going to be shift to the right. Okay, I am going to show you here again. So let's take a look. So if I add 5 to the whole function, the red one is the original one. I add 5 at the end, that means you shift up vertically. And now compare to this one, y equals to x minus, let's use plus 5 squared. That means what? If you plus a number, you shift to the left, not to the right, because I made a mistake verbally in our first demonstration. But do you see the difference between these two? One is you add it at the end of the whole function. The other one is you add it inside of s. You're just working towards the x. So why is that? Well, you can think about that. Our fx is what? Basically is our y coordinate, right? So if you want to change the y coordinate plus or minus some number, that means it's what? You're working something on the vertical direction. That means you either move up or move down. So if you're doing something to x, that means you're working on the x coordinate, which is the horizontal coordinate. So that means everything is going to change. It's going to be a horizontally change. Okay, so after shifting and adding, we will have reflection. So again, we have a vertical reflection and a horizontal reflection. So what is vertical reflection? Well, now let's take a look at our graph. So look at this graph. If I take this as the original function, I want them to reflect vertically. That means it's going to mirror the x-axis. The functions look like this, right? So now the purple one and the red one, they reflection to each other vertically. So that means reflection is we need to take a negative sign to the whole function. So it's going to look like that. So this gives you a vertical reflection. So now make a guess. What does a horizontal reflection look like? Well, a horizontal reflection, of course, you're going to work towards x. You just want to take the negative to x. So now take a look on this graph. So x squared maybe is not the best example because if it's a horizontal reflection, then going to overlap, okay? So now I'm going to use a different one, maybe s to the cube. So now s to the cube, the red one, when I reflect the s to the cube, horizontally, what does it look like? It's going to be, you flip them upside down. When you connect these two, they were what? Symmetric to each other vertically. Or I can work on the square root one, which is square root of x. It look like that. So what does it look like if I want this to have a horizontal reflection? It's going to flip to the other side. Okay, so that's visually show you what does a reflection look like. All right, so the next one is going to be a compression and stretches. This one is a little bit tricky, but is also not that hard. So vertical, stretchy, or compression. So again, if it's a vertical compression, it's going to, what does it look like? You can think about, let me grab something very quick. So now take a look. This is stretchy. So vertically stretchy, that means the graph is going to look like that, right? So that means horizontally it's going to look like slimmer, right? But if you compress them horizontally, what does it look like? It's going to look like a fatter, right? Okay, so now let's take a look. Vertically compression, which one is going to be a vertically compression? You multiply some number to the whole function, you will see a vertical changes. All right. So now take a look. Again, use our x squared ones. All right. So this is x squared. So if I want them multiple to x squared, this is what? Well, it looks slimmer, right? That means what? You stretch them vertically, because when you stretch them, they're going to look slimmer. Okay, so what does a compression look like? A compression look like is when you multiply some number is less than 1 but greater than 0, because once it's less than 0, give you a negative number. What happened to negative number? We talked about that earlier. If it's negative, it gives you a vertical reflection. Okay, so now take a look at the black one. Compare the black graph to the red one. It's getting fatter, right? Horizontally, it's fatter. That means you are vertically compress the graph. All right. So now we have a conclusion. If A is greater than 1, then the graph stretch vertically. And then if in between 1 to 0, that means it's a fraction less than 1 or decimal, the graph is going to be compresses vertically. Now we're just talking about vertically, because horizontally would be different. Horizontally is you multiply some number for x, not to the whole function. So now, what does horizontal and vertical, horizontal stretching and the compression look like? Well, we know that it has to be multiply some number just to x, not to the whole function, because if you work something horizontally, you want something that just in x. Okay, so now let's look at our graph. Oops. Okay, if I just want to use x multiplied by 2 times x, what does the purple one look like? Okay, you may say, hey, this is look like stretch vertically, but think about it. We are talking about horizontal. Let's look horizontal. What does the horizontal changes from the red to the purple? It get compressed because you get slimmer. That means you were being compressed, right? So now, what if I multiply some number that less than 1.2? Well, you're getting fatter, right? If you're getting fatter, like these stretchy sleeves, you're going to be what? Stretchy. So that means if you multiply a number greater than 1, the graph is going to be compressed horizontally. But if you multiply a number between 1 to 0, the graph is going to be stretched horizontally. Again, if you forgot, please go to decimal.com to check it out, the graph, and do the experiments like I did. So these are the rules for the transformation of the function. So what does this do? Well, this is very powerful because from now on, you don't need a calculator to help you to calculate the basic function. So remember, we have the toolkit function, right? We have y equals to a constant number, which is a constant function such as y equals to 4. We have identity function. We have a x squared, which is quadratic function. We have a cubic function. We also have square root function. We have cubic root function. We have reciprocal function. We have squared reciprocal function. What else? Oh, we also have absolute value function. So how does this relate to a function transformation? So if I tell you that, hey, could you give me a graph about 2x minus 4 squared plus 5, what does the function look like? Well, you see there's a square. The first step is you need to identify the basic or the toolkit or the parent function. In this case, you see a square. Well, then you know that, well, most likely the function is come from y equals to x squared, right? And then the next step is you take a look at, you have times 2, you minus 4, and then you plus 5. You know the function starting with x squared, and then the first transformation is you subtract 4 from x. So your function will become this one after you subtract 4 from x. So your function will become x minus 4 and then square. Well, if originally your function looked like this, because we already learned all of the basic function, what do they look like? This part, which here is 0, 0, and then you subtract 4. Remember, subtracting from x is a horizontal shift to the right. So that means you shift to here 4 units. So your function is going to look like this one. That's your new function. Okay, let me use a red pen for the new function. Right, that's how you horizontally shift to the right 4 unit. All right, so the next step is, after you subtracting 4, the next step is what? You multiply 2 from what? You didn't subtract them from x. This time you didn't multiply 2 from x. You from y, right? Because you multiply the whole function. If you just multiply 2 from x, the function should look like 2 times x minus 4 squared, right? That means you're only working towards the x. All right, so the function is going to become fx, and then you multiply the whole function. That means you multiply fx, multiply the y. So the function look like that. Well, if in multiplication, this is going to be either stretch or compress. And we know that since it's multiple from y, that means it's going to be a vertical transformation. Well, multiplied by 2, that means this is going to be what? If it's greater than 1, the function is going to stretch vertically. So that means our function, from our last step, the function in here for 0, after it stretch vertically, the function looks like slimmer, maybe look like this one. Also, it shouldn't shift or change anything. The vertex should remain the same at 4 and 0. All right, so now what's the next step? The next step is you add 5 to the function, right? To the whole function. That means you plus 5 from y. So that means the function is going to have some transformation on the vertical axis. Oh, you add 5. What does it look like? If you add or subtracting a number, it's going to be a shift. At 5, that means you're going to shift up 5 units. So from our last function, the function looks slimmer in here for 0. And now it's going to shift up to here, right? For 5, because the vertex is going to move up. So that's your final function. Another example could be, let me think. this one. If I'm giving you a function, I ask you on what interval is the function g of x equals to -2 s minus 1 squared plus 3 increasing and decreasing. Okay, so now what does an increasing function look like? That means the function going up, decreasing function is the function going down. So the first step is you need to know, hey, what is the original function look like? What is the parent function look like? Well, these have a square and the x is the bottom. So these look like a toolkit from our toolkit function what? Reciprocal square function. That is the original function or is the parent function. Everything comes from there and transform into a different function. Okay, so the first thing is what? Well, I can subtract 1, right? You subtract 1 gives you what? You subtract 1, first of all, you need to identify if this is come from vertical or horizontal. Well, you subtract 1 from x, so you have the function fx equals to x minus 1 and then square. That means the function is going to be shift to the right 1 unit. Well, what does reciprocal function look like? A reciprocal function originally looked like this one, right? Now you shift to the right 1 unit. So that means the function is going to look like something like this, right? So in these, from the first step, where is the increasing function, increasing interval? Well, the increasing interval should be what? From -infinity to +1, right? Because originally, the increasing interval should be from -infinity to +infinity. Since you shift to the right 1 unit, so that means the increasing interval moved to the right as well. And then where is the decreasing interval? If you look at the graph, you may easy to identify it's going to be 1 to +infinity. Okay, now the next step is we take a look. 8 times 2 or times -2. Well, we can consider that's 2 transformation. One is you times a negative number and then you multiply by 2. So we can do it separately, but trust me, later when you get used to this transformation, you will do it in one step. Just multiply in -2. Okay, now I'm going to separate them. You times 2 from y, right? Not from x. Because your function is looking like 2 over x minus 1 squared. Okay, when you multiply a number to y, you know that it's going to be stretched or compressed vertically. So since 2 is greater than 1, it's not a fraction. So that means this is going to be stretched vertically. Okay, so the function, I should show you the asymptote. So this is -1. The function looks like this. When you stretch them, it's going to look slimmer, but basically it should be the same, right? So think about when you stretch them, should be more like outside a little bit. All right, you can also check it with decimal. And then after you times 2, the next step is, okay, let's continue. Where is the increasing interval? Increasing interval should remain the same from negative infinity to negative 1. That's increasing interval. And then from 1 to positive infinity, this gives you a decreasing interval. Look at the red graph. That's our new graph. So now I times negative 1 from y. So your function becomes negative 2 over x minus 1 squared. If it's negative, that means you're going to have a vertical reflection. So from the last graph, your function looked like this one, right? And then you reflect them vertically, so your functions look like this one. So now your increasing and decreasing intervals should change. So now from negative infinity to negative 1, this has become your decreasing interval. I'm going to use this for our decreasing sign. And then from negative 1 to positive infinity, this is going to be an increasing interval, because the graph is increasing as x gets bigger. All right, so what's the next? The next is you add 3 at the end of the function. Well, what happens if you add 3? You add 3 from y, not from x. So your function is going to become fx equals to negative 2 over x minus 1 squared at 3. So that means the whole function shifts up. So you may see that there is a asymptote in here. They never pass the x-axis. So since they add 3, you are going to have what? A vertical shift up 3 units. So that means your function is going to be from something look like this way. You still have these x equals to 1 asymptote, and the whole function shift up. So that means your function may look like this one. So this is going to be what? 3, right? The horizontal asymptote is going to be 3. So that means your increasing interval should remain the same from the previous step, which is from negative 1 to negative infinity to 1. This is going to be your decreasing interval. Let me write this nicely. And then your increasing interval should be 1 to infinity, because from that you're going up. So here is very powerful about the function transformation. Of course, we can do more about it. And we can also ask you, hey, from where the function is concave up and concave down, and ask you how to draw a function. So that's it for the function transformation. I'll see you next time.